So welcome back you guys. In this video I'm really excited because we are going to start the real meat of machine learning. We are going to start simple linear regression. We are going to start coding in this video itself. I'm really excited. Hope you are also excited with me. Let's get up and keep coding. In this video we will cover simple linear regression. Along with that, we'll discuss Pandas, Matplotlib and Numpy Python libraries, what they do and how can we implement in simple linear regression, right? We are going to split our data into training set and test set, and we'll also see how to predict values after training our data using training set. We will see how to compare our predicted value to that of its original value. We are going to see the accuracy of our trained model using R square, and we are going to visualize our linear regression with that of training set and that of test set. So a simple linear regression is given like this: y is equals to ax plus b. Y is the dependent variable, x is the independent variable, and a is the coefficient of x, and it is also called as the slope. B is the constant. Suppose this is our data points, right? And this is the x axis and this is the y axis. This is the dependent variable and this is the independent variable line. So now we have to find the perfect or the better linear regression line. Is it this line, or this line, or this line? So if you see the second line, this line is passing through both the data points, and this is close to this and this data point. And if you see comparative to all of these data or comparative to all of these lines, this line is much better, and this line here, the first line, is the worst because this is not passing through any of the data point, but the third one is passing through one and the fourth one is also passing through one data point. So we can conclude that the second point linear regression line is better because it's passing through two data points. So let us move on now. So what is Pandas? Pandas is a Python library which gives us functionalities to perform data manipulation or data analysis. For example, we can read or write into data, or we can aggregate the data, or we can merge the data, right? So Numpy is used to do mathematical calculations such as square root or squaring of a number. The special part of Numpy is it allows us to do mathematical calculations on multidimensional arrays like 4D and 5D type of arrays. We can do mathematical calculations on those. Matplotlib is a Python library which allows us to do data visualization. We can plot the data into pictographs, histographs, bar graphs, and different types of graphs. So now we are inside our Google Collaboratory. So let us write here simple linear regression. And the first thing when we are coding simple linear regression is we have to import libraries. Import Pandas as PD. Let us import it like import library, importing libraries. So let us import our libraries, right? Import Pandas as PD. So Pandas is now PD. So we are importing Pandas as PD as short form, and import Numpy in the short form of NP. Okay, and import our matplotlib for visualization, matplotlib dot pyplot for visualization as plt. Let us run it. Yeah, we found success in running it. Now we have to fetch our data set. Okay, so fetching our data set, fetching data set, right? Go on, click on this icon, file icon, and go to documents and click where the CSV file is located. I'll keep a link of this file in the description below. Okay, and now we are going to fetching our data set. Let us name it as data set, right? And we know that we use Panda for data manipulation. Now we are going to read a CSV file. Let us copy the path here, copy the path inside single quotes, bam, we have copied the path. Now here we divide our data set into two parts, the independent variable and the dependent variable. So here the independent variable x is equal to the data set which is containing all rows. The column before the space before the column indicates it's starting from 0, and the space after the column indicates that it should be till the end, right? So all the rows from 0 index to the last index, and we want all the rows, and the second part of and after the comma we indicate columns, right? We want all the columns except the last column. Here we want, let us see here, we want all the columns. That means we want this column except this column. So what we do, if we don't want the last column, we simply say -1. We don't want to include the last column here, so -1 stands for the last column, and we don't want to include the last column, right? So -1 indicates that the column before the last column dot values. So here the iloc is the location of I. Here I is all the rows from 0 to the end, and all the rows and the columns from 0 to the first column. Here just we are having one column, so it's like from one column we just want to include one column, and we want to escape the last column, so we use -1. That means the column before the last column. And values, we want the values of these data, right? And y is equal to data set dot iloc means location, and we want the location of all the rows of this. That means a space, the space before the column indicates 0. That means we want to start it from the very beginning, and the space after the column indicates that we want all the columns until the end. And semicolon, we only want to include the last column. That means -1. -1 indicates the last column. Values. So let us run it. Yeah, cool. Let us print out the values of x and y. X print y. So this is 1.1, 1.3, 1. This and so on till 1.10.5, correct. And this should be this values. So this values, yeah, absolutely correct. 3 3 3 9 3 4 3, correct. All the values are correct, and the last value is like 1 2 1, yeah, correct. So now we have to split the data into the training set and the test set. We are going to train our data on the training set here. So now we are going to split the data into training set and test set. Training set is used to train the linear regression. Splitting the data into test set and training set. So now we are going to split the data into training set and test set. Using training set, we are going to train our regression line. So we have to split the data. Splitting the data into training set and test set. So let us go. So to split the data, we are using a very famous library called as sklearn or skidlearn. So from sklearn dot model selection import train test split, right? So the return type of train test split are 4 variables. One is xtrain, second is xtest, and third is ytrain, and fourth is ytest. Xtrain comma xtest comma ytrain comma So here xtrain is the independent variable of training set, and xtest is independent variable of test set. Here ytrain is dependent variable of training set. Here ytest is dependent variable of test set. So we are going to split our model into training and test set. Here x is the dependent variable, y is the independent variable from what we have calculated here. The test size here is 0.2. That means here the test size is equals to 0.2. That means that our test set is the 20% of our whole data, and the training size is 80% of our total data set. So let us print the values of xtrain, xtest, ytrain and ytest. 4 quotes, print train print xtest print y train print y test. Let us run it. Success. Yeah, we got these values from the training set. This is our independent values from training data, and this is independent value of test data, and this is the dependent value of our training data. This is, oh, this is an error, sorry, the while y is small. Yeah, this is the dependent value of our test data. So for our better understanding of training and test set, let us say from here to here is our training data. Let us say, for example, yeah, I'm not literally meaning it, yeah. So let us say this from here to here is our training data, and this from 9 to 10.5 is our test data. This part is called as dependent this part is called as independent variable, and this part is called as dependent variable. So from here to here it is x train, and from here to here it is y train, and this from here to here is x test, and here to here is y test. So hope you understand what is x test and y test, x train and y train. So let us now train our linear regression. Training linear regression using training data. That means x test, that means x train and y train. We are going to train on this. Here the libraries are ordered in their alphabetical order, P, C and so on. So we have to find linear regression, right? Let us go down, down, down. So yeah, linear model. So we want linear regression here, yeah, from here. Let us go here. So the syntax is, it looks like this. Let us copy whole of this. So why am I showing you this docs? Because I want to make you independent. So even without me, without any tutorial videos on YouTube, you can by your own self go to these docs and learn machine learning, right? Copy up this thing, copy, and move on to our code. Paste it. Now what we have to do, we have to follow the syntax from sklearn and this, and just before this dot we have to delete and import linear regression. Now create a object of linear regression, linear regression. Now we have created an object. Now the real part, we have to train our data set, training data on linear regression. So for that, for that, regressor dot fit means we are training it on x train, comma y train. Fit means training the data. We are training the data. Let us see if we get the object here. Yeah, we got an object here. Now it's time to predict our values of x test using this regression model. Predicting values of X test. Now let us create an predicted variable. Now let us create an predicted variable y pred is equal to, we are going to predict values using the fitted object here, right? Regressor is the fitted object. Using that we are going to predict. So we are going to use this predict method and we want to predict X test. Let us see what the answer is. Let us print it out. Print X test. So this is the predicted value of X test. Now let us compare the values of predicted value of let us print it out, and bravo, we got the predicted value of X test. So let us now compare our predicted value to that of its original value. So we have to compare predicted value to that of its original value. So now we will use Numpy to predict. So now we will use Numpy to concatenate predicted value to its original value. np dot concatenate. So as you can see here, concatenate will take both parameters if we are passing the concatenated objects, right? We have to take two parentheses, and one is y pred comma y test. Let us run it. This is our y pred from here to here, and this is our y test, the original value. So let us from here, so this is our predicted value and this is our original value. So for a better visualization, what we will do, we will stack up predicted value, and now what we will do for better visualization, we will stack up this predicted value and y test value so that it be side by side. So we are going to reshape it into row, as a row, not as a column. This whole part is a column, right? Now we will do it as a row. So we have to reshape, take two arguments here. One is the size of the row. So the size of the row should be y length of y pred, and the column size should be 1. So just we want one column, right? We want it in a vertical way, and we also want to reshape it here. Reshape length y test. The size of the row should be of the size of y test. So here the size of y test is 1 2 3 4 5 6. So there should be 6 number of rows vertically, and there should be only one column, right? Let us print it out. Bravo, we got it. So this is our predicted value and this is our original value. You can see so much similarities in this both. So our training, now let us stack predicted value and original value side by side. So for that we have to add 1 here. Bravo. Let's see here. So for this value, this is our predicted value and this is our original value. This is our predicted value and this is our original value. So well done. We have predicted this machine learning. So well done. This machine learning model has predicted kind of accurate results. Yes. See, this is a bad prediction because this is like 3,000, 36,000 something, and this is 46,000 something. This is a slightly bad result. So let us find accuracy of our model using R square. Text R square. Add the code here. So let us again go to sklearn API. So here R square, yeah, here we got it, R square. Let us copy this, copy and paste it over here and follow the syntax. From import R square score print R square score so let us now print our R square result. Print R square y pred to that of y test. Let us see our accuracy. The predicted model is really good. It's 98% accurate. That's really good. Now let us visualize training set with the linear regression we predicted, right? So let us now visualize our training set data with that of our predicted linear regression line. Visualize training set with linear regression line. Code. Yeah. Now we use matplotlib for visualization, right? PLT. Scroll up and see we have imported matplotlib.pyplot as short form for PLT. Right? You will use PLT. Now we will give the values of label, right? PLT dot x label. Here it will give we will give the label for x. The label for x, let us see what it is here. X, this is x, and the label here is x years of experience. Years of experience. And PLT dot y label. Y label here is salary. And the title of our graph will be x versus y, right? Years of experience versus salary. Now let us plot our line. Dot plot, and we want to plot our line, which takes x train as x-axis and regress and bipred, and we'll give the color blue. And now let us also visualize the points of our data set. Scatter x train comma y train comma color is equals to, let us give any color like red. Red will be nice. Oh no, we are getting an error. Oh yeah, I get it. Ypred is in here is the predicted value of x test, but we want predicted value of, we want now predicted value of x train, right? Regressor, we want predicted value of x train. Now let us see. Yes, it worked out. So this is our linear regression line that we have developed. So this is our linear regression line here, and this is our data points. This is our x train data points. This and this. It's a very accurate result because on this line nearby, like there are 1, 2, 3, 4, 5, 6, 7 data points lying, and most of the points are nearby. So this is a good linear regression line. Let us visualize it against our test set, right? Visualizing lies linear regression line with test set. Good. Yeah, it will be similar to that of training set. So copy it, copy cell, and where's the paste? Yeah, let us paste. Control V, and we just have to change. Yeah, we are predicting test values, right? Test value and predicted value of test. We are scattering test, x test and y test. So this is our linear regression line, and this is our test set data points. So this gives a really accurate result. See, as you can see, this linear regression line is passing through both of these points, and this line is also close to all of these data points. So this linear regression line predicts pretty much accurate results. So yeah. So now we have completed our linear regression model. Hope you liked this video, and if you liked it, please share, subscribe and like it, because it took a lot of effort from my side to make this tutorial. So happy coding, happy machine learning. Signing off, Salman in Tech.